Welcome back for another warm-up quiz. Pencils ready, piece of paper, here we go. So here's our girl on the roof again, being naughty, dropping a ball. What model or physics model is the best choice to describe the ball as it falls? So would it be the constant speed model, the uniform acceleration model, or the balance forces model? Pause the video if you need to. And I'm moving on to question 2. Okay, here's our famous cat sitting on the roof. It's a sloped roof. And given the forces, I've given a whole force diagram all drawn there. Which of these following vector addition diagrams is correct? So definitely pause this video now because you're going to have to work through each one individually to make sure it's correct. Moving on to question 3. Got a formula triangle here, or following triangle, and one of the forces is the normal force. And what formula would you put together to calculate that will help you calculate that normal force? And I'll give you a big clue here. You need to first identify where the 90 degree is in the triangle. So pause here because this will be having to work through your SOHCAHTOAs. And then when you're ready, here I go to question 4. All right, so I've got just a trig equation here, and there's no triangle, can you just go through the working out to rearrange it to find x? You don't need to calculate it on your calculator, just rearrange it. All right, so pause, and we're about to go through the answers. Right, answer number 1. So when a little girl drops a ball off the roof, the ball starts to speed up. If I was to draw my motion map, it goes further and further each second. So here's my velocity. It's most definitely not a constant speed model. Okay. When she lets go of the ball and the ball's falling, if I was to draw forces on the ball, I always draw, it's meant to be down, but I'm just struggling. Force of gravity on the ball. Is there anything in contact with this ball? Any other objects interacting with it as it falls? No. Maybe as it gets really, really fast, there might be a little bit of air resistance. So friction from the air. But I would say, by and large, there's nothing else. So is it a balanced forces model? Definitely not. So it only can be uniform acceleration. Cat sitting on the roof, I've given you the forces, and I want you to put these together as a vector addition diagram. I mean, this is the answer. We're going to talk through each one of these individually because these 2 wrong answers are very common mistakes for people to have. And so there'll be times when you actually put these in. This first one at the top is a common mistake because you get your forces here, and instead of actually putting them together in a vector diagram properly, the common mistake is people see this triangle the cat's sitting on, and they copy that triangle as their vector addition diagram. If you look carefully at this, the normal force goes out to the left and the friction force is really big, which is not the case in the actual diagram. The only reason I've done this is because they've copied this triangle the cat's sitting on. So the triangle the cat's sitting on is not the forces. So that's a common mistake. A second common mistake that happens is that when we draw, and I often draw my downwards, I'm going to put this on an angle so I can draw things straight. My gravity first, and then I do my normal next. Now the normal up here is not the same size as gravity. It's a bit smaller. And often people draw this normal force up so it goes to the same height as gravity, and then they draw this last one just going straight across. And that's not the case because this friction force is not straight across, it's up the slope of the hill. Okay, and the only way that can fit in is if you have a downwards force. This one is not as big, and then we have the last one, which is what we've actually got over here. So 2 common mistakes there. And that's the reason I asked that question. If you've given this vector addition diagram, which is the correct answer, if you look carefully, it's the correct answer. I've just copied it, put some numbers in. How would I calculate Fn? Now, this is the process you're going to be going through today. First thing I do is identify the right angle, which looks to be here, and then I label my hypotenuse, opposite, and adjacent. So here's my angle, the right angle. The hypotenuse is always the longest one, and it's a bit hard to tell here, but it's always opposite the right angle. So this is opposite the right angle, so the hypotenuse is over here. That's my first one I've identified. And it helped because I had the right angle. Now that I've got this angle here, this is my adjacent to that angle, and then opposite that angle is over here. So then I write my SOHCAHTOA. SOHCAHTOA. What have I got? I've got adjacent and hypotenuse, which is CAH. So I've got cos 36 equals adjacent, which is normal force, divided by 46. And that's that one down here. And last one, let's say it's 3 marks. I want to find x. It's divided by 24. This is actually a bit easy. Now, the only thing, there's nothing, there's the answer. Some of you might have said cos 13 times 24. Just be careful that on your calculator doesn't try and do that and then cos it. You really want to have cos 13 and that number times 24. In your rearranging, I'm not too worried, but just when you've got to use your calculator, I like to write anything times the cos. I like to write it before it. It's just how I do it. Okay, I'll see you in the rest of the lesson.